Have you ever wondered, what's the best thing of the night sky? Is it the city lights? Or fireworks? Or maybe the moon? Aha! Much beyond that, quietly twinkling stars. If you look at the stars every night, you must have tried to count them.
This version is for preview only.
What
Commercial
are those,
exhibition
and how
of the
come
film
they are
is
so
prohibited.
many? Quite frankly, we have one sun, one moon, but countless number of stars. Let me tell you something about those twinkling, sparkly dots. A star is a big ball of gas that constantly gives off heat and light. They are born in a very colorful region of our universe called nebula. In their spectacular home, they evolve and change over time, just like us. They vary in size, mass, and temperature. It usually takes billions of years for a star to complete its life cycle. Do you know the closest star to us, and also the one which is visible in the broad daylight? That's our sun. Quite right. Our sun is also a star, or as far as the stars family go, a very average one. There are many other stars, far bigger or smaller, brighter or fainter, or hotter or cooler than our sun.
This version is
However,
for preview only.
our sun
Commercial
is the largest
exhibition of the
object
film
in our
is
solar
prohibited.
system. It contains more than 99% of the total mass of the solar system. It is also quite essential for the life on Earth. Our sun is almost 4.6 billion years old, and it has enough fuel left to live on another 5 billion years. But do you know what will happen to our sun after? All stars are formed from a nebula. A nebula is an interstellar cloud of dust and plasma. We also call it a stellar nursery. Here the stars grow and enter into one of the two pathways of their life. Depending on its size, the star either becomes a main sequence star or a massive star. Our sun is a main sequence star. This kind of star lives by burning the hydrogen within its core and turning it into helium. We know this process as nuclear fusion. The sun has a very huge force of gravity in its center. This gravity pushes the sun inward, whereas the burning of hydrogen creates an outward pressure. As a result, the sun stays stable and in the same shape. all the hydrogen is used up, the helium core starts to contract further. Because of the extreme force of gravity in the core, the helium fuses into carbon. The outer layer of the Sun keeps on expanding, cooling down, and slowly loosening their shine.
This version
This
is for
expanding
preview only.
Sun
Commercial
turns into a
exhibition
giant.
of the film is prohibited.
No, not that type of giant. The Sun finally turns into a faint, big, red ball of leftover gas, which is called a red giant. What happens after that? Our red giant Sun still keeps on eating all the helium and turns it into carbon. But when all the helium is also finished, the Sun doesn't stay hot enough to burn the carbon it created. The outer layer drifts away as a gaseous shell and surrounds the core. We call it a planetary nebula. The inner core shrinks down further and becomes the densest forms of matter. We call it a white dwarf. Most white dwarfs are extremely hot and remain hot for a long time. The smaller the dwarf, denser and hotter it is. But as time passes, they also dim and cool down. Do you think that's the end of our Sun? Well, not exactly. When it stops shining, a white dwarf turns into a black dwarf and stays that way forever. Since they are black, they stay invisible to our eyes. So, after many years from now, the Sun will be a black dwarf. It will stay at the same place, but will not be visible at all. That was the story of our Sun, or to be precise, suns like all the main sequence stars. But if you may recall, I've told you earlier that there are also other types of stars in the nebula. These are called massive stars, or also known as blue supergiants. Massive stars also evolve in a similar fashion until they reach its main sequence stage. These stars have much higher amounts of gases in them. Similarly, they stay steady and shiny until all their hydrogen is burnt up. After that, the massive stars turn into a red supergiant. They keep on expanding for a long time, way bigger than the earlier seen red giants. Their core is also massively
This version
denser
is
than
for
a
preview
red
only.
giant's core.
Commercial exhibition
As a
of the film
result,
is prohibited.
someday their core collapses under its own weight. The process emits a huge amount of energy and shockwaves and turns the star into a supernova. For a short time, newborn supernova shines brighter than the entire galaxy. The remaining core of the supernova is very dense but amazingly small in size. It is now called a neutron star. Some of the neutron stars emit jets of powerful light beams at their poles. They are called a pulsar. But sometimes the surviving core is again pretty great in size. This super dense great core doesn't convert into a neutron star or pulsar. Instead, it contracts even further and becomes a black hole. Black holes are the most powerful objects in the entire universe. Their gravity is so high that even the light cannot escape it. And because no light can escape it, they are completely black and invisible to us.
This version is for preview only. Commercial exhibition of the film is prohibited.
So now you know that how much amazing action is taking place in each and every star above the sky. And I'm sure you're convinced the stars are the best thing you can see in the sky, even better than fireworks.